In this example, we're asked to determine whether this series, negative 1 to the n minus 1 over 3 plus 5n, as n goes from 1 to infinity, the sum, we're asked to determine whether this series is convergent or divergent. So I like to abbreviate this question as C or D, convergent or divergent. And we notice that this series has this term, negative 1 to a power. You have to always check the power, so negative 1 to the n is what we're maybe used to. Negative 1 to the n minus 1, negative 1 to the n plus 1. These are okay. So in any of these cases, what happens is that the value of this starts at either plus or minus 1. Let's just say plus 1. It always depends on where your n starts, your index. In this case, it will start at plus 1 because 1 minus 1 is 0. Negative 1 to the 0 is 1. And then it goes minus 1, plus 1, minus 1, plus 1, etc. Okay, and so in this case, we think this could be an alternating series. This looks a lot like it could be an alternating series. Of course, that portion is definitely alternating. We have to check the rest of it to make sure that it obeys the alternating series criteria. So, what do we look at? Well, when in our alternating series, these are generally written in the form sum negative 1 to, again, some power. I'll write this as n minus 1 since that's what we've got, times some series, some terms of a sequence b sub n. And the criteria on this sequence b sub n are that all of its terms have to eventually be positive, or at least non-negative. Okay, that the b sub n should be decreasing. Excuse me. So b sub n plus 1 should be less than b sub n for all n. Again, greater than or equal to wherever the starting point is, and so this is where we get into the conversation that it should be eventually decreasing, but for here let's just say greater than or equal to 1. Okay, if these two things apply, then we can apply the alternating series test. Let's first make sure that these criteria apply. So our b sub n for this series is the sequence whose terms are 1 over 3 plus 5 times n. Okay, now again, remember our n is starting at 1, and then it's counting up. It cannot become negative. N can't be negative in these series problems. So this is of course positive. It's positive kind of by default. It's greater than 0 for all n because there are no negative terms here, right? So we don't have to worry too much about this. Sometimes this is harder to check than other times, but for this particular series, that's just obvious. And then the next criteria is actually not that hard to check either. You can just think about how this is working, right? But b sub n plus 1 is going to be 1 over 3 times 5 plus n plus 1. Okay, 1 over 3 plus 5 times n plus 1. And then if you distribute this out, what you end up with is 1 over 3 plus 5, so that's 8 plus 5n. And of course, as n is getting bigger, 8 is bigger than 3, right? And so this term is actually smaller than 1 over 3 plus 5 times n, which is b sub n. And again, this is true for all n. And the reason that the left-hand side is smaller is because the denominator has gotten bigger. And of course, this reciprocal relationship means as the bottom gets larger, the entire fraction is smaller. Okay, so there's our decreasing. So we've got a positive sequence decreasing, and now it starts to alternate. So now we have verified that the criteria of the alternating series test are met for this series. All right, and we can analyze this using the alternating series test. So I'll just write AST for alternating series test. Now, once these two criteria are met, the alternating series test is very, very simple. And it says that this series converges if and only if the limit of the b sub n series is equal to 0. That's all we have to check. If this limit is anything else, then it's going to be divergent. And that's actually a function of the test for divergence. But the big news here is that since we've verified that this is an alternating series, we really only need to check that the limit of the positive part is equal to 0. So let's do it. Once we actually for this one, once we've checked that it's alternating, the limit is actually not that big of a deal because the limit of the b sub n is just 1 over 3 plus 5n. Remember, the limit in a series, with a sequence, the only limit that makes sense is the limit as n approaches infinity. Okay, and if we're going to go through this and do this the official proper way, then what we need to do is multiply both the top and the bottom of this fraction by 1 over n. Alright, and what we end up with then is that this is the limit as n approaches infinity. 1 over n divided by 1 over n plus 5. Alright, and as n gets very large, this term 1 over n, this is 3 over n on the bottom, but 1 over n or 3 over n, constant over n, these two limits are going to go to 0, right? As n gets very large, those become 0, and so this becomes 0 over 5, which is of course 0. Alright, again, that's what we want in the alternating series test. Well, we want whatever it gives us, but this tells us then, this gives us a conclusion by the alternating series test. Our series n from 1 to infinity, -1 to n minus 1 over 3 plus 5n, this series is convergent. Notice that we do not know what it converges to. We could work that out, but we don't know what this converges to. We just know that it is convergent. And that was the only question we were asked on this